All right, it's that time. Feel free to move up if you want to. You won't have to take notes or anything if you want to occupy one of these empty tables here. Or don't, however you're comfortable. Um, cool. As long as everybody can read the screen and you're comfortable, then we're good. While everybody's moving around, I'll do a little intro because I didn't get the pleasure of helping all of you on Tuesday. I helped some of you. My name is Andy. I'm a part-time lecturer and mentor with Lighthouse Labs. I am an alumni as well, so not a horrendously long time ago, I was right where you are now. I don't have a computer science background. I'm not like a computer engineering student. I worked in a warehouse for 20 years. And then I decided, maybe I want to get into tech. I think I'd rather, make money with this and doing this than hurt myself in a warehouse and freezing in the winter and stuff like that. So if that resonated with anybody and you want to talk about like, hey, I'm not from this. This is so foreign to me. What's it like to work in this field? Things like that. If you have any questions, feel free to reach out to me. Other than that, I don't really have any quirky facts. I really love algorithms. So if you have an awesome algorithm, let me know. But today, how's the font size for everybody in the back? You good? Thumbs up, send an emoji. Awesome, thank you. Some feedback. First off, my lecturing style. Everybody here is different, and there's a method to that. Like some people you will really sync up with. Some people you'll be like, I'm on the same page as them. Other people you're like, I wish Nima did it. So hopefully you don't say that too many times. But I like to have to-dos because it helps keep me focused because I tend to go on tangents because I really like this stuff. So I'll dig into the details and then I'll be like, whoa, we need to come back. So these kind of keep me honest, as well as I love to ask questions during lecture. I think this is like give and take because otherwise you might as well be at home watching a YouTube video or a Udemy tutorial or something, right? You paid a lot of money to be here to get educated. So if you have a question, there are no silly, dumb, stupid questions. Odds are other people have that question too. Okay. The other reason why I ask questions during lecture is I'm not going to get a lot of responses. I'm going to be honest with you. Most of the time I get no replies whatsoever. Okay. I'm hoping that's not the case with this cohort, but you never know. But even if you're not going to shout out an answer or raise your hand, think about the question. Think about whether you have an answer to that. If I say, what does HTML stand for, or why do we use HTTP? I want you to think about it, because as developers, we should have some kind of idea about things. We should always be making a guess about what our code is going to do before we run it, that kind of thing. So even if you're not going to say it out loud, at least do me a favor and, think about what your answer would be if you were to raise your hand. But I get the pleasure to talk to you today about something that you're going to use every single day for the rest of this, your time at Lighthouse, as well as pretty much every single day on the job as a dev. Okay. So no pressure. You don't callbacks. And so there's various different ways to introduce callbacks to people. People really struggle with this concept, typically. We'll see people in week 4, week 5, week 6 who are still like, I don't fully understand what a callback is. Okay. So my technique that I've developed is I'm just going to give you the definition of a callback right up front. And then we're going to come back to it at different points in the lecture and see if it makes any more sense than it did right now. Okay. So, dun dun dun. Does anyone know what a callback is off the start before we get? Yes. A callback is a function that gets passed to another function, and we can add on to be invoked by that function. Okay, that is exactly what a callback is. No more, no less. And this probably doesn't make a lot of sense right now, but hopefully by noon, it will make a lot more sense. I really enjoy this lecture because it's less about the theory and typing things out and just talking at you and more live coding. So we're going to jump right into it. I am in a reasonably empty directory. All I have is a README that I've prepared. But I want to be able to share these notes with you later. I want to push them to GitHub. So what is my first step? You talked about this with Carl on Tuesday. What do I have to do so that I can share this code later? Git and init. I like it. There we go. Initialized an empty Git repository in here. And then if I run ls-la, I can see, does everybody know what the A flags do? It's so that you can see hidden files on your system, right? So there we go. We now have a Git directory. And if I run git status, hey, no commits yet, one untracked file. Yes. Okay, excellent question right off the hop. Is this equivalent to this? And they're not, and I'll show you the output. So lowercase a, so any of the A's will show you hidden files. I use capital A because what's different about what came back here from what came back here? Yes. Yeah, we see these, which are actually little programs. This is why you can do things like cd ... That's exactly what those are. But I typically don't need to see those because I know they're in every directory. So if you run ls-l capital A, you just eliminate those, but you can see all your other hidden files. Anything that starts with a period is hidden by default. Okay? And then LAH. Let's just do H. So you can see the difference between here. We saw it was 651 somethings. And here, the H stands for human readable. It turns your file sizes into something that you can read. You'll see bytes or kilobytes or megabytes there instead. So H just stands for human readable, so you'll often see things like LAH, putting them all together. I want to see the hidden files, and I want this to be human readable. Normally, I'm not super concerned with file size, so I don't usually throw in the H. All right, where were we? Okay, so if I run git status, I see that I have an untracked file. What do I need to do in order to track this file, to let Git know about it? Add it. Awesome. So I can say add README. Does everybody know about the tab autocomplete? Awesome. Fantastic. Remember, devs are lazy. Okay? We don't like to type. I'm going to say that over and over. So I can either add the files individually or I can do my favorite, which is period. Then I can run git status again. No commits yet. Changes to be committed. There's my new file. Okay, so let's say I've added something to here. This is just a refresher for Tuesday. We get a lot of questions about Git and how it works. Okay, so I added this. I ran git add. I added this file to be tracked, and then I go later, oh my gosh, I don't want to do that. How do I remove this from being staged to commit? Sorry? Git R. Git R. RM. Oh yes, you could actually mention the file name there. But we got another one up here that gave it away. It suggested git reset. Let's see what happens. So we run git status, and then I run git reset. And then I run git status again. Hey, we're back to untracked. So you can git rm and remove a particular file if you want, or you can git reset, and essentially it does the exact opposite of git add everything. Cool? Awesome. So time for my first commit. Sorry? Yes. Yeah, because you notice that it got annoyed. Usage. This is the improper usage, so it's suggesting that I should use it in a different way. So where are we? Git status. There we go. And git commit -m initial commit. Awesome. Git status. Master branch is clean. Fantastic. Okay, so I'm going to create a new file, jump back into VS Code, and here we go. Okay, so if I want to store something, this syntax should look pretty familiar to everybody, right? What exactly is this line of code doing? Now, I don't ask trick questions. That's another thing about me. These are straight up. What does this line of code do? It declares a variable called name and puts the string Andy into it. I'll also tend to repeat questions or comments for the recording. Okay, if students watching in the future, or if we have a remote cohort who's also tuning in. That's exactly what happens. So it should come as no surprise what will happen when I console log this. Node values, Andy. There we go. Exactly. Okay, so we can do this with various different things, right? We can have, what do we have as values in JavaScript? What can we store inside of variables? String, integer, Boolean. Function. Thank you. Objects. Arrays. I think that's, I mean, we've covered the majority of them. So why don't we take a look at those? I need an integer. So I'll go with number of toes, 10. Sure. And is awake true. Okay. So I want to get these values back. I want to add them to a console log. I can do that, right? We should be able to see something like num toes. We'd expect to see 10 written to the console, right? This shouldn't be a big thing for everybody, right? Awesome. So if we're gonna move on from there, somebody suggested functions, that we could store a function in a variable. How can we declare our functions? We have two different methods of declaring functions, right? How do we declare functions in JavaScript? We'll talk about arrow functions in a bit, and you do some reading today on arrow functions. But that's not one of the two that maybe I can start it off like this. Is everybody familiar with this syntax? What if we did something like say hello? Have I just declared a function? Right? Awesome. And then inside, I'm going to say console log. Is everyone okay with backtick string interpolation? Or do you prefer the plus signs? String interpolation is good? Okay, awesome. Okay, so we're going to console log, hello, name. Okay, if I run this file, what's going to happen? Name is undefined. Some people say nothing. Does everybody have a guess in their head about what's going to happen when I run this file? It's going to print hello, Andy. Okay. Nada. Absolutely nothing. This is a common thing that we see as mentors when we come to help students, is I wrote the code, the function looks fine. What did I forget to do? I have to call the function, exactly. So now, what am I going to see? Let me get rid of these for a second. Okay. What are we going to get from this program now? Hello? Hello, Andy. Awesome. So how did JavaScript know that to put in this into here? Sorry? It is a global variable. Well, so what does it mean to be global? Yes, it's available to all the code that's written inside the file, right? If we had something inside of here, let's say another var equals something else, and we were going to try to write this one out, would I be able to console log here another var? No. Okay, that's right. Because we have this concept of scope. All variables have scope. So another var is scoped to this function, right? We could only use it inside of this function, and children if we had something like another function declared inside of here, right? We can't use it in the global scope. Okay, so what if I do something like this? Aim equals, what is this code going to output? Hello, Mark. Let's find out. Hello, Mark. Awesome. And why is that? Sorry? That's right. That's correct. So when you when you say when you say a variable's name, you want to try to retrieve the value from memory, right? So JavaScript will look inside the local scope and say, is there a variable called name inside this local scope? And if there is, it will use that. And if there isn't, it will move up and up and up till it hits the global scope. And it says, oh, there we go. We'll plug that one in instead. Okay. So what will happen if I do this? Name is not defined. Reference error. Name is not defined. Exactly. Sorry about the green. I believe I'm living in the matrix. You'll get used to it as I lecture more and more. Cool. So what if we want to extend the functionality of this program? What if we don't just want to have to declare a global variable? How would we have something that's specific to say hello? We could pass name to the function. So if I did something like this, is that going to work? Right. So we have to add that in as an argument here. Okay. So I know we're going over and over and over this, but I really want to make sure that everybody's on the same page. What is this going to print out? Clear? Hello, Mark. Awesome. Okay. So what is this going to print out? Andy? Some people say hello, Andy. Anything else? Are we going to get a reference error? Are we going to get some kind of big output in the console? What are we going to see? Undefined, perhaps? Let's find out. Hello, undefined. Cool. So why did we get undefined? Why didn't we get that reference error? Or why didn't we get the value? That's right. So anything that we say as an argument in here, it's another way of saying to JavaScript, like, let name equals whatever was passed in. Right? So essentially, all we've done is we've done let name, right? And what happens? I'm just going to console log this out for a second. So if I say let other name, console log other name, what are we going to see? Undefined. That's right. I don't even need to run the code. So because there's a difference between a variable declaration and if we said something like this, a variable, definition. Okay. So on this line, we're actually declaring the variable, and then on this line, we're defining it. That's why if I comment this line of code out, we get back undefined, because we've declared it, but we haven't yet defined it. So every variable in JavaScript starts as undefined. It's a bucket in memory. Nemo likes to talk about them like buckets in memory that you can put values in, but it's going to be undefined by default, right? Okay, so let's see what else we can do with this. What else can we pass to this function? Does this need to be name? No? Some people say yes, some people say no. What if I said this was text? What are we going to see? Hello, Mark. Exactly. This cohort is on it. This is fantastic. Cool. If I'm moving too slowly or too quickly, make sure to let me know. If you want clarity on anything, interrupt me. Otherwise, I'll just continue to blather away up here. Cool. So we're reasonably comfortable with values in JavaScript, right? So can I do something like what would we get from this? True. And why is that? Why do we know, how do we know that still awake is true? Yes, because it's setting to is awake, and the value for is awake is true, so it still awake becomes true, right? Awesome. So that means that we can pass these things around, and we can continue to pass them around, right? What is the other function syntax that we have? We can assign it to a variable, exactly. We could have, say, hello equals function text. And then I can just steal this line here. Copy, paste. Awesome. So we can see that we should hope that there's no functional difference here, right? If we comment that out, what would we expect to see? We call hello. We should see hello mark. Let's see it. Absolutely. So these are equivalent for most intents and purposes, right? We've just said this is a variable, and here's the value to put into that variable. Awesome. So let's see what else we can do with this. What if I said, what's going to happen? Hello, Mark. Exactly. Hello, Mark. So how come we can do that? How come we can just pass this say hello function around? And what's with this? Why down here when we want to use a function, we have to invoke it, right? We put the parens on it. What's with this? Sorry? It is a function object, absolutely. Everything in JavaScript is an object, except for the primitive values. But it is a function, but it's a function as a value, right? So we can pass it around to various different things. Okay, so we all know what would happen if I ran it. What's this going to do? I don't have the parens. I'm not passing any arguments. What happens if I just straight up console log it? Let's find out. Function. And notice that it says the function's name is say hello, but I console logged say hello too. I just want to make that really clear. Same result, do you think? So we declared say hello, we gave it a value. Then we declared say hello to, and we gave it a value. Then we declared another func, gave it a value, and then we're going to console log it. What are we going to see? Same thing. It's just a function called say hello. Exactly. And I believe that if we actually want to see something fun, hey, there we go. So if we concatenate on toString, which the majority of objects have in JavaScript, then we can actually see what's inside of the function. And there we go. That's the value of the function came back. Okay, or the value of this variable. So we have a couple different ways that we can look at this. We can say its name and get back the function itself, right? We'll get back say hello. Or we can invoke it, and then the code inside the function will run. Right? Okay, is that making sense? 1024. Awesome. But are we any closer to understanding callbacks? I'm not sure. Any questions around functions as values that we can just pass them around like this? Can we? The one that I commented out, can we pass this one around in the same way? Let's find out. So we didn't assign it to a constant. We just said function say hello, the old style syntax. Does everybody have a guess about what's going to happen? Hello undefined, undefined. Interesting. So even though we have this say hello function, we didn't store it in a variable. We can still make reference to it in the same way. We could still invoke and see that. Hello Mark, hello undefined, undefined. I just realized I've been saying hello Mark over and over and over. If anybody's seen the room, no? Okay. Anyway. I also tend to make references, maybe that's my thing. I make references that nobody gets. Cool. Say hello to? On line 13. Oh. Well, this will be interesting. What's this going to do? Okay, let's find out. Reference error. Say hello to is not defined. But you'll notice we didn't get that it didn't exist, just that it wasn't defined. And this is because of something called hoisting, which is beyond the scope of today's lecture. Okay, but yeah, not good practice to try to use a variable before you've declared it, or use a function before you've declared it, right? You want to declare all your stuff at the top of the file and then do work at the bottom of the file, right? Awesome. Okay, so we can't pass those around, but we can pass these ones around. Cool. So we know that we can assign functions to variables. We know that we can pass them around just like we passed around the isAwake variable, and we hang on to that. And we've talked about the fact that invoking a function, calling say hello, will run the code inside the function. And just saying say hello, if we console log that, would give us back literally the value from this. Okay? Awesome. So this leads us down to, I should probably leave that there for right now. Let's touch another file. Callback.js. And I'm going to grab our say hello because it's so much fun. Here we go. Callback.js. Okay. So we have, if we say that functions are values, and we say that functions can accept values, what's the natural evolution of those two thoughts? Functions are values, and functions can accept values as arguments. Where does that lead us to? Functions can accept other functions. Awesome. So let's take a look at that. So I like this say hello function. I like when my computer says hello to me. I think this is cool. We've got this encapsulated in say hello. Why don't we declare another function called run my function equals a function. It's going to take in a function as an argument. I'll just shorthand it to fn there. And then inside of here, if I'm going to accept a function, if I'm going to do something like run my function, say hello, if I've passed this in as a value, I've stored it in fn, right? So how do I run this function now? How do I run say hello inside of run my function? Let's try it. Return fn. Ooh, like that? With the parens? Okay. Does everybody have a guess about what this code is going to do? Awesome. So let me just run over it again. We've got our fantastic say hello function that accepts one argument and then says hello argument. And then get rid of this so we can see it all together. There we go. Then we declared run my function, right? Which is yet another function that accepts a function as an argument. And then we're returning the invoked function. And then down here we're saying run my function and we're passing say hello as an argument to it. Let's see, I gotta type this one out. node callback. Hello undefined. Exactly. And why did it come back as hello undefined? We're not passing any arguments to it. So how would I pass Mark or any name to say hello, to get it to say something other than hello undefined? How would I get Mark into text? Pass it to FN? Oh, on the last line? Can we pass it to here? Mark. Let's find out. Type error. This is a good one. This is one we haven't seen yet. FN is not a function. Is anybody surprised by this result? A little, maybe? Why? Why did we get, when we tried to invoke FN, we got FN is not a function? That's correct. So down here, we are actually invoking the function. We're not making reference to it. We're actually literally invoking it right here. So if we put this on 2 lines, it would be the equivalent of result equals hello Mark, run my function result. And of course, what would come back from say hello? What's the return value of say hello? Undefined. That's right. So if we, this is gonna, FN is still not a function, and we actually, oh, it threw the first time. So since this is undefined, in here we're trying to do that. And of course that's not gonna work for us. Okay, so what if we said, instead of console logging hello, what if we just return it? Is that going to fix our problem? Now we're not console logging. Now this function actually has a return value. What are we going to get now? Hello, Mark? Maybe it'll fail because we're still using a string as a function. And it failed. FN is not a function because once again, inside of here, we were saying, hello, Mark. And we all know that's not going to work, right? You can't invoke a string, right? So that brings us back to, how do we get Mark inside of say hello? We could pass another argument to run my function. We absolutely could. We could say, let's take in a name. And then we can pass in Mark here. And then how do we get Mark into say hello? Put it into FN. Cool. Let's take a look at this. Everybody has a guess? Clear the console. We have to use console log if we want to actually see anything. Exactly. So say hello is no longer console logging. Let's return that to a console log. Get rid of this one. Let's see that again. Hello, Mark. Okay. But this isn't incredibly useful, right? Why would we pass a function and an argument to another function to just put those two together? That's not really useful to us, is it? We might as well have just invoked the function to begin with, if we're going to do that, right? Why would we go through this rigmarole of, I mean, that's super cool and all, that we're passing functions to functions and they're invoking them. But this is not a really great way of using it. What does this do? Is this going to give us a reference error? Is it going to give us a type error? Is it going to be happy and just execute the code? I need like a drum roll sound effect or something. Name is not defined because we're no longer accepting it as an argument, right? Okay, so how do we realistically get Mark into this function? Well, we could just pop it in right here, right? We could say, whatever this function is, whatever was passed in, whatever stored in fn, I'm going to invoke it and give it an argument of Mark. Okay, so if we run this now, hello Mark, cool. What if we want to pass another function to run my function? We like to make things extensible, meaning we can reuse them over and over, and we can extend their functionality in different ways. What if I pass another function to it? What are we going to see now? Is everyone aware that console log is a function that we pass arguments to? Yeah. Okay. So fn, I'll just comment this out for a second. Fn is now going to be console log. So what do we expect to see? Mark. Exactly. So that is the equivalent of running console log Mark. Exactly. Everybody keeping up? Am I going too slow? Is this kind of sinking in? I want to really work on this because I want you to understand it by lunch today. I want you to be able to definitively say, this is a callback. That's my goal as a lecturer. Cool. So we now have a function set up called run my function here. And we can actually rename this to make it a little more clear. We have a special name for functions that accept other functions. We call those higher order functions. And ostensibly, there is no real difference. We said that primitives are values, objects are values, functions are values. This is a function that accepts a value and does something with it. We just have this special name. We like to, give names to things. It's just one of the things we like to do. So we call this a higher order function. And it simply means it accepts a function as a parameter. Okay? So if you see that anywhere, and then we can just invoke it later. So what are we looking at? 1037. We are moving right along. Let's check out our to-dos. Functions as values. We talked about that. We talked about the scope chain. Remember, with all the different names and seeing where they were, right? We even talked about function calling versus function passing. If we want to call it, we invoke it, right? We put the parens on. If we want to pass it, we don't put the parens on because then we want to get its value back, right? And then we delved into callback functions and higher order functions. Wow, we are really scooting along. This lecture is going to be done by 11. Next up. Any questions so far? Please. Yes. Okay. So is this the callback or is this the callback? Who thinks say hello is the callback? Who thinks higher order function is the callback? Sorry? Depends on the way that it's used, exactly. But in this particular situation, which one of these is the callback? Both of them. What would make you say both of them? Oh, console log is absolutely a function right here. And console log is a function that we're actually using as a callback. The callback itself is the function that we pass to the other function. You'll in fact see this oftentimes, that it's either callback or CB in here. In other words, saying the thing that gets passed in is the callback, right? So we're used to seeing console log, we just write it in our code. But here we're actually passing it as a callback. We're saying in here, at some point in the future, invoke this function. That's it. So did that answer your question? Awesome. Any other questions about callbacks so far? Okay. So we're back around to everybody's favorite name, or maybe it's just my favorite name. I don't know. And then we can console log name. And what are we going to see? Obviously, we're going to see the contents of name, whatever this is. I'll make it Mark, so I'm not saying my own name over and over. We would see Mark, right? What's the difference between this one and this one? As far as users of our code are concerned, they're going to see the exact same thing, right? If we node, what did I call this, a non, we see Mark Mark. So as far as a consumer of our code, another dev or someone using our library, they're not going to see any difference in the output. What is the difference to us as developers? That's an excellent reason to pull it out to a variable. If we're going to reuse the value over and over throughout our file, that we were making reference to name, we were passing it around, maybe we're doing other things, we would want to keep track of this and move it to another variable. So that is a very good reason to pull it out to here. But kind of what I was looking for is the fact that we've gone through the trouble of naming this. Here, we've just passed it in. Here we just said, hey, console log this string. But we could have stored it in a variable first, right? Yes. So if this was like Dolores, then we'd see Dolores Mark, right? Because this one is hard-coded in there. It's a literal value that we're passing it. You've heard about these literal things, right? We have things like array literals. We have things like object literals. Something like that. This is what's called an object literal, right? So we're literally passing in Mark into here. Cool. Does anybody have a suggestion for a string manipulation thing, or should we just continue to go with say hello? Say hello work for everybody? Okay, let's set up our say hello function again. Console.log. Hello text. Okay, same old near and dear function that we've seen. And we've seen that we can pass, and we could do something like that. We could invoke say hello, right? We could also, if we had ourselves a nice higher order function like this, we could accept this in, and we could pass it here, and we could say higher order function and pass in say hello. We've already established what we'll get back from this, right? Okay, this is exactly the same as our other file. So what if we decided instead that for the same reason that we can do, we had name and we stored it in a variable and then we passed it to console log, or we passed in the literal string Mark to console log, we saw the output was the same. What if I do, since we already have a console log, I don't need to console log here. Higher order function. What is this going to do? Everybody have a guess? Kind of a guess? Well, what's going to happen? Was that confusing to anyone? Why we saw hello Mark as the output of this? Yes? No? Yeah? Okay. Awesome. It's good to be a little confused. KV likes to say, get comfortable with being uncomfortable. This is something you're going to have to come to terms with as a dev. The dev world is just too big for everyone anyone to learn everything there is to know about it, right? We're always going to be running up against things that we don't understand, that we don't know. And it's being comfortable with the fact that you're not going to understand it and that someone's going to teach it to you, or you're just going to have to figure it out on your own, and getting comfortable with that uncomfortableness of just not knowing. Because when I was in warehousing, it was probably 6 months into my first job. I knew pretty much all there was to know about warehousing, right? And you've probably worked same thing. If you're working in a dish pit or something, 3 months, 6 months in, you know how that dishwasher works. You know how to get clean plates back out to the staff, right? You're never going to get to that level of like knowledge with computer programming, because it's just, the ecosystem is just too big. So we have to come to terms with the fact that we are going to get surprised, and there's things that we just don't know. Okay? So, what is, if we don't think about that anymore, and we come back to this? Marl? Mark. What's the difference between these two? One more time. In this one, we chose to store the value in a variable first, and then pass the variable in. In this one, we chose to literally just write the string directly into there. Okay? So, if we come back up here, what did we do with higher order function? We know that it accepts a function as a callback. So rather than put the function into memory, I just took the body of the function and put it right in line. I passed it as a function literal. Exactly. It's the same thing we did here. We could either store it in a variable and pass it in, or we could just do it right in line. So the body of this function here, I just pulled it out and put it right inside. And so we talked about one of the advantages of naming something is that we can use it later, right? What's a disadvantage of naming something? I can give you one. Google's on top of it. There are two hard things in computer programming. Are you ready for this? There are two hard things in computer science: cache invalidation and naming things. And I like to think about this as, usually you want to end on a high note, you want to stress the ending. So I would say that naming things is probably harder than cache invalidation based on that. Right? Naming things is hard. You got to come up with a name for this. I had to come up with a name and say, okay, this function is going to be called say hello, and pass it in. This one, I didn't have to bother. I didn't have to give it a name at all. I just passed it in as a literal. Just like down here, I didn't have to store this in a variable first. I didn't have to name it. I didn't have to do anything. So what would we call someone who doesn't have a name? Someone who doesn't want to be known? We would use a word like anonymous, right? Not identified by name, of unknown name. And it means the exact same thing in programming. Anonymous, without a name. This function has no name. So it's an anonymous function. That's literally all there is to understanding anonymous functions. And other than naming is hard, are there other reasons why we would want to use anonymous functions? Yeah, a lot of times you just get used to the syntax of writing things in line. It makes your code a little easier to read. It can also make your code easier to read to pull it out. It depends on where you're going. Can anyone think of an example in the last 3 days where you've used a function that accepted another function? Sorry? Sorry, there's a lot of noise in the back. Any console log, as long as you were console logging the function, as in you were saying, I want the output, but the true To truly say that it is a callback function means that it was invoked by the function that you gave it to. You said, here's some encapsulated code, take it into your function and invoke it at some later point. And you don't really do that with console log, right? Usually we're passing in a value or an interpolated value. Only, well, console log is not actually, we're, yes, yes. I guess in that sense, then it would be a callback. As long as the function is being passed to another function and being invoked, then it's a callback. But we actually have some built-in JavaScript functions that you've been using already. And I'm probably going to give it away. I have an array. What are my options for printing this array to the console or doing something with it or performing some kind of math on this array of values? I want to iterate over each thing in the array. What are my options? For each. Excellent choice. What is the syntax for each? Yeah, we actually pass in a function that accepts the element. Oh, I'm jumping ahead of myself. Function that accepts the element, and then we can do something with it, right? We're just going to console log it for right now. But what are we going to see from, what do we expect to be output to the console from this function, from our for each? 1, 2, 3, let's find out. 1, 2, 3, exactly. We've been using, everyone here has used for each already, right? You were already using a function that takes another function. This is a method on the array object. Method is just a fancy word for function that accepts another function. To fully illustrate that, what's this going to do? 1, then 2, then 3. In this situation, we passed in a named function. We took the time to put it into memory. In the previous one that I had, r.forEach, we just declared the function in line without naming it. We passed in an anonymous function. But you've actually already been using these, right? We have other ones. We have map. We have filter that will operate on some collection of values. In this case, they'll iterate over them. And then they'll execute some encapsulated code that you've passed it. 10:53. We're almost ready for break. Actually, why don't we go a little early? That way we don't conflict with anything. And think about why this might be advantageous to us. Why did the developers of JavaScript, the people who wrote the language, give us this method that takes in a callback function? Cool. I'll let you think about that for 10 minutes. I'll see you shortly. All right. I think everybody's back for the most part. Is everybody ready for round two? Did any questions surface over the break? Or was everybody just eager to grab coffee and water and try desperately to stay awake? All right, cool. Awesome. So I left you with a question, I believe. What do I say? We're into a non. Why would this be advantageous? Why is it advantageous to us to be able to have a function that can accept another function? So you don't need to run around to find out where else it's defined. That's true. That's one reason to pass it inline. But what about just the concept of a function that takes another function? What does for each do? And then what does this inline function or my func do? Let's illustrate this another way. I need an array that we can iterate over. We should probably go with like an array of strings or something like that. Just something fun. Do we have a noun? Anything? Mark. Const marks. So it's various different marks. So it'll be like Zuckerberg. Is it Zuckerberg? Wahlberg, right? Is it Berg or is it Berg? I'm not sure. Any other marks that end in Berg? Any other marks? Ruffalo? Cool? Okay, we're good. Thank you. We have marks, and we're going to iterate over marks. Okay, so we live in a world where JavaScript never invented the for each method. It never happened. But we want to be able to iterate over these and do something to each one. We want to say hello to each one, let's say. That's original, right? Okay, awesome. How are we going to do it? You've read this in Compass. They said, here's an array. We want to print each one of these to the console and say hello in front of them. A for loop. Yeah, absolutely. So what do we have available to us for for loops? We have the C-style for loop, right? We have the for of. We have for in. What do we like? Do we like the C-style one? Does that make the most sense to everybody? Let I equal 0 kind of thing? We call this a C-style for loop because it looks a lot like loops in C. There's really not very much depth to us. It's just like naming is hard, and the other thing that we kind of see is what you get. We are very much WYSIWYG. If anyone's familiar with that term. What you see is what you get. Cool. C-style for loops. There we go. Okay. So let I equal 0. I is less than marks.length. Excellent. And then I++, right? We want to step through and we want to see each one. And then inside of here, we want to do something to it, right? We want to console log. Let's do a couple of steps. Let's say, yeah, we'll call it converted name equals, how do we make reference to a particular mark inside of our marks array? Square bracket syntax, that's right. And what are we looking at here? Are we looking at like 1, I, awesome. Cool. So what is going to be stored in converted name the first time through the loop? Yes. There we go. So have we accomplished our task? Let's make this even more convoluted. Okay. Have we accomplished our task? What's going to happen when I run separation.js? in the console. Hello, Mr. Zuckerberg. Hello, Mr. Wahlberg. Hello, Mr. Ruffalo. Was that a surprise to anyone? That's what you've been doing for the last 3 days, right? Iterating over arrays, looping through, looking at the values. But what are we doing here? We're actually doing two things, right? We're actually doing two things at the same time. We are iterating over the array with our C-style for loop, and then we're doing something to each one of the values, right? So we have this code that's going to be run for each one of the values, which we're making reference to with marks at I. But we're also looping over each one. First time through it's Zuckerberg, then it's Wahlberg, then it's Ruffalo, right? So we like the idea of separation of concerns. Why should our code be so tied to, I want to iterate through an array? You can imagine that, I mean, you've iterated through how many arrays now? Dozens, right? Wouldn't it be nice if we just had a function that just iterated over an array and then performs some kind of work on each element in that array? That'd be pretty handy, right? So how do we encapsulate functionality together? Oh, I kind of gave it away. How do we encapsulate functionality? In a function. Exactly. So if we were going to pull this out to a function, then we might have something like const say hello, for lack of a better term. This function is going to accept some kind of value. And here, instead of marks, we're going to say name, right? Because we want this to be a variable. Now, we still live in a world without array.forEach. So why don't we write our own for each? But to put a little bit of a spin on it, why don't we write our own for each that will loop through an array in reverse? Yes, I see raised eyebrow. Cool, awesome. So I want to create my own for each. How do I get started? It's going to be a function, right? Function keyword. There's the body. One of the things I like to do as I'm coding along is I always like to put in my closing braces and everything. It helps me not to get confused. I'll see other coders, you know, just start typing down and they're like, okay, I need a closing brace and another closing, and then I just do it all as I go because it makes it a lot easier for me. Cool. Okay, so what is our for each function going to have to accept as an argument? An array. Let's just call that R, because we want to be as generic as possible, right? We want this to be able to loop over any array. Okay, so we've got R, and inside of here, why don't we use our classic C-style for loop? How do we know when to stop? R.length, right? We want to be dynamic. Why, it wouldn't be backwards, would it? So where do we start it if we want to go backwards? Is it -1? That's right. Why is it -1? Because arrays are 0 index. That's right. And then when do we stop? At 0. So could we say greater than or equal to 0, right? Because we want this to be evaluated. And so as long as I is greater than or equal to 0, we're going to continue through here. And then we need to decrement I on every. Thank you. Pair programming. It catches those bugs. Okay, so I think we can agree that we're going to walk backwards through an array, right? So now we come to our next thing. What does for each do for us? So we've taken one piece of this logic out. We had it all encapsulated together here. We were saying very literally, we are walking through the marks array. Then we're going to do something to each element, right? So what is our function missing that for each gives us? We need to do something, right, inside of the code. So what method do we now have for encapsulating logic and moving it around between functions? Starts with a C. It rhymes with all backs. Cool, okay. Yes, so we need to accept some kind of callback, right? Something, I'll call it callback just for clarity. And then what do we want to do inside of our loop? We want to call the callback, right? We want to invoke this callback, whatever it was. But we also want to be able to, there's no point in looping through an array and then just firing a function a number of times. We actually want to get the particular mark, right? So how do we pass the particular mark that we're on to the callback function? R at I. Exactly. Okay, so we have all three pieces of our puzzle now. We have an array that we want to iterate over. We have some specific functionality that's specific to this array, right? Because if this was an array of numbers or something, then we get hello, Mr. 1. Not making a lot of sense. So this logic is particular to this array, right? So we have all of the pieces of our puzzle now. We've got our array, we've got our function, and we've got our new for each that we've just added to the JavaScript language. This is great. So how do we put all these pieces together? Sorry? Yes. Okay, so let's call for each. For each accepts an array as an argument, right? And we have that as marks. And then it accepts a callback. So what callback do we want to pass? Say hello. And we don't want to do this, right? We want to pass it in as the function because we want this to be able to be invoked later. Okay, let's take a look. We've all got guesses about what's going to happen? Cool. Let's find out. Hello, Mr. Ruffalo. Hello, Mr. Wahlberg. Hello, Mr. Zuckerberg. It looks like we were able to successfully walk backwards through the array, right? And at the same time, we created our own, I'll make sure this is named correctly, for each in reverse. But we also managed to accomplish something else. We were able to strip these two things that we were doing into two separate actions. Because iterating over the array and performing some functionality on each element in the array are two separate ideas that we have, right? So we were able to create a function that we could use over and over and over and over on any array, and it will walk any array backwards. And we also created very hyper-specific functionality for this particular array. Okay? And we're able to put those two together. And that's one of the main reasons why we really like callbacks, because we're able to separate things like looping and running through something from what we're actually going to do. We can separate those logically, right? And you've been doing this kind of incidentally by using array.forEach over the last 3 days, right? Awesome. Any questions about our for each in reverse that we created? Yes. So is it still called a callback? Let's find out. So I think if we get down to it, we'd have something like say hello, takes in a name. Oh, we actually want to say const equals function, takes in a name, and then we'll just say that it console logs name. And then we're going to do, well, we won't actually, we need an array. So let's grab this. We've got our array of marks. And then we want to do something like marks.forEach, right? And so you're asking, is it still a callback if we did something like, we know that this is going to take in, we know that forEach takes a callback function, right? But your question is it still called a callback if we do something like this? Because now we're not actually passing it to a function. This is the function that gets passed in. So this here is the callback. This is not a callback. So in this situation, say hello is not being used as a callback function because we are invoking it ourselves. We're saying explicitly, say hello. The thing about a callback is we're passing it to some other part of our code and saying, you invoke this. You invoke it at some future time. You invoke it every single time you loop through an array. You invoke it when you get some data back from the server. You invoke it when a customer logs in. We don't say when we invoke it. Whereas here, we're saying, I say hello. I'm invoking the function and I'm passing an argument to it. Okay? Good question. Any other questions about separations or callbacks in general? Oh, good so far? Awesome. Okay, so we had an intro to anonymous functions. They're just functions without a name, right? Now we're going to move on to arrow functions. Okay, so what is an arrow function? So we can have const, say hello, everybody's favorite function, takes in a name, and console logs the name. Cool. This could also be written as an arrow function. And the thing about arrow functions, let me just copy this. The thing about arrow functions is all you have to do is remove the keyword function and add an arrow in between the arguments and the actual block of code that's going to run. And that's it. That's the only, as far as we're concerned right now, there are some things around the JavaScript keyword this that's different between an arrow function and a function. But if you're not making reference to this, then you can safely use an arrow function anywhere you would use a normal function. So putting them side by side, we can see, remember the statement I made a while ago that said, programmers are lazy? There's the two of them side by side. So we like the syntax of an arrow function because it's very concise. It's a lot easier to do something like, if we had our marks array, just so that this doesn't error out on me, marks.forEach element, and then we can just pass it in. It's very simple syntax. In fact, it's the natural syntax for me. I've had to correct myself a couple of times already, of just putting in an arrow function instead. It's nice and clean. It's easier to read. And since we use callbacks and you're going to use them every single day, it just makes it a lot nicer. You don't have to have that function word in here and then get rid of this, that kind of thing. We just remove the word function and put an arrow in between the arguments and the curly braces. Okay. There are some other shorthands that we can use for this. If you only have one argument, you can actually get rid of the parens around the argument, and JavaScript won't object. If you only have one line of code inside of your function, you can actually get rid of the curly braces, and JavaScript will not object. This function is equivalent in functionality to this one. But you can see that syntactically, it's quite a bit shorter, right? This is why we lean towards arrow functions, just because the syntax is just shorter and easier to read, I think, once you get used to seeing this arrow. You'll sometimes hear this referred to as a fat arrow function. And the reason why is because in other programming languages, they actually have a skinny arrow as well. We do not have the skinny arrow function in JavaScript yet. I don't know if we ever will. I don't know if it's on the roadmap, but all we have available to us is this. But we still kind of force a habit. People call it a fat arrow function. So you'll hear those used interchangeably. It just means arrow function. Okay. I prefer not to use this particular shortened syntax because for a number of reasons. It's hard for new developers to reason about. You want to make sure that the code that you write, everyone on your team understands. This is definitely not an industry where you want to be smarter than everybody in the room and prove it to everybody. Okay? We want to be able to write code that people 5 years from now who have never met us long after we moved on can maintain our code. So you don't want to be as like, oh, people are going to look at this code and they're going to be like, beautiful, so nice, I love this code. But I have absolutely no idea what it's doing. I have no idea how to refactor it. And I can't maintain this code. I'm scared to touch anything because it might break because I don't fully understand it. You want code that everyone on your team knows how to read, right? So I prefer not to do this approach. That's one reason why I don't do it. The other reason is because let's say we want to go back afterwards and we've decided that say hello is now going to take an index as well or something like that. Well, now we have to remember to put our parens back on. Now we're going to do something with the index as well. Well, now we have to put our curly braces back on. You never know when you're going to jump back into the code and have to add a line or add a console log for debugging or do something like that. So I prefer to always put the parens on and always put the curly braces on. That's just me. You can do what you like. But I prefer this because it means that I don't have to remember to do it later when I change my code. Okay. So any questions about arrow functions? How are we doing for time? Almost 11:30. We're actually zipping along. Does everybody kind of understand arrow functions? Maybe, sort of. Okay. Oh, it entirely revolves around this. In a nutshell, what the fat arrow function does, the reason why we're concerned about this, and this is actually completely beyond the scope of the lecture, so I'll just talk about it very, very briefly, is this is a special keyword that makes reference to the function that was invoked. Okay, so inside of here, console.log this, if we were to look at this, actually, we'll do it up here. So inside of a regular function, this makes reference to the function itself. However, arrow functions do not rename the this keyword that they get. They use the parent's name. So inside of a fat arrow function, this refers to the global syntax. The global object. Okay? So that's really the only big tripping up point is the value of this changes inside of an arrow function. It's might not be what you expect it to be. Yes. Yeah, anything inside of an object when we start, you can probably make a reference to it if you're adding methods or something to an object. You can use this to make reference to the object itself. It's whatever invoked the function, whatever called it, is your this. But you'll do some readings on that and you'll have time to come to terms with that later. I want to focus on callbacks and arrow functions and all kinds of fun stuff. Any other questions about arrow functions? It really just is absolutely as simple as erasing the function word and just putting in the arrow. Otherwise, they're exactly the same. Okay. All right, let's check out our README. How are we doing? Arrow functions. We only have one left, and we've already done our own version of for each. Should we tackle our own version of filter? Cool. Touch filter.js. Okay. So, let's start by thinking about this. What does filter do? It's an array method, right? We would invoke it with something like array.filter. Right? So, what does filter do? creates a new array. And what's inside that array? It's passed in. Now, are they changed in filter? Included or excluded. And this probably doesn't make any sense. Contents of the array that was passed in are included or excluded, right? Based on a Boolean value. We're going to put in some kind of test, some kind of condition, and if the element passes the test, we put it into that, we keep it, and if it doesn't pass the test, we get rid of it. We're filtering the array, right? So, we need an example array to walk through. We've use marks again? Is everybody okay with just using marks? Cool. So, we're going to need to declare our own version of filter. So, it's going to be a function. Okay, so just like for each, what is our filter going to do? It's going to need to accept an array, right? And we're going to do our old C-style for loop, right? I is less than r.length, I plus plus. So we're going to iterate over the array, and then what do we want to do inside of our... We need to evaluate the condition, right? Because the way that filter works, if we said marks.filter, that's going to work, yeah. Const new marks equals, because it returns a new array, right? So we have to set that to something. It doesn't actually mutate the array in place. And this is important to remember. Filter and map create a whole new array for us. Okay, so now we can console log new marks. And what is going to be the value inside of new marks? What is new marks going to be? Let's find out. Node filter, an array with one element, Zuckerberg, because that is the only element that we have that passed this test. If we did it the opposite way, name does not equal Zuckerberg, we'll get back an array with two values in it, Wahlberg and Ruffalo, because again, this time through, they passed the test, right? Awesome. So, we need to accept something, don't we? A callback of some kind. Okay, but before what we were doing was we were saying callback on r at I. Right? Well, let's carry this logic through, and let's have our filter function. There's going to be a function that accepts a name. We can even use arrow function syntax, so we get used to seeing that. And then we are going to return name does not equal Berg. Name does not equal Zuckerberg. Okay. So, and we are going to invoke our filter. We'll take in the marks array and our filter function. And we know that we're going to get back a new array. So we'll call this new marks equals, and then we'll console log new marks. Are we done? This was as far as we went with for each. We just called the callback on each element, right? What is this going to do for us right now? It's going to return a Boolean for each. Okay, does everybody have a guess? Undefined. Why is new marks undefined? Sorry? Well, I actually am calling our filter function that we wrote right here, and I'm setting the new marks equal to whatever the return value is from our new filter function. But why did we not get our array of, did we say equals? Not equal. Why didn't we get this? Why did we get undefined? Our filter function doesn't return anything. That's exactly right. And in JavaScript, we have the idea that every single function needs to return something. It essentially needs to return control back to, like when we execute filter here, it's going to go into here, it's going to iterate over the array, it's going to call our callback function on each one, but then at some point it stops running, right? So it needs to return control back to this code, our global code, so that we can execute the line 20. Otherwise, if we never returned, we'd be sitting on line 19 forever. And you'll see this when you start making web servers. If you set up a web server that listens but doesn't return, then the client will just hang forever. Okay? So JavaScript got around this by saying every function is going to have a return value whether you say it or not, right? So we actually have this concept of an implicit return. But JavaScript didn't want to make any guesses about what you want, what kind of functionality you want. So if you don't specify a return value, we just get back undefined. So that's what we're seeing. This is equivalent to exactly what was happening. If we save this and run this code, we'll get back undefined. Because our filter function was, now we're explicitly returning undefined. Undefined, there we go, undefined. But if we comment this line out, we are implicitly returning. As in, we didn't have to say anything, we didn't do anything, we didn't specify a return value, therefore, the return value will be the default of undefined. Okay, so we need to fix this. Luckily, we have ample time. We have 23 minutes to fix our filter function so that it actually returns something. What do we want to return? What do you get back from filter? What did we get back here when we used the built-in filter? We got back an array, right? So how are we going to set up? Sorry? The callback? So how are we going to utilize the callback to get an array back of results for us so that we see, next time we run it, I want to see Wahlberg and Ruffalo. What do we need to do? We ultimately want to return something, right? What do we want to return? We want to return an array of some kind, right? But if we just do this, getting closer. We are almost there. We're just short a couple of strings. I could just hard code them in here. Okay. So we know that our callback function that we've created, our filter function, is going to return a Boolean value. It's either going to return true or false. Either the name equals Zuckerberg or it doesn't equal Zuckerberg, and it's going to return true or false. This is shorthand, by the way, if you're not familiar with this. A naive approach might be to do something like this. If name does not equal Zuckerberg, return true, else return false. So these two lines of code are equivalent. The reason why we do this, if you ever find yourself returning true or returning false, those are your two answers. Usually you can just return the condition. Because JavaScript has this idea of falsy values, right? You've already looked at those. What are some falsy values in JavaScript? 0, undefined, empty string, null, nan. These are things that, but they're false-y. They're like false. They can be used like false, but they are not false, right? But for our, so why don't we, if this, so what an if does is you say if, you evaluate this condition, and then you execute either the first one or if it fails, the second one, right? So we can actually just return the condition. We can actually just say why. This is going to evaluate to true or false, so why do we have to explicitly return true or return false? So that's why we can do this all just on one line, because this will evaluate to either true or false, and then we'll move on. Okay, cool. So we want to say if our callback evaluates to true, right? We don't have to say, again, explicitly, does this equal true, right? Because we have this concept of truthy and falsy values. If conditionals will work just as well with truthy values and falsy values as they do with true and false. So we can just say, execute this callback. The return value is going to be a Boolean, either true or false. And we're only interested in if it returns true because we're filtering, right? So then what do we do? We're inside of here. We've established that we've hit Wahlberg. We said, does Wahlberg not equal Zuckerberg? Well, that's true. Cool. So we're inside of our if now. Okay. So we need an array, right? We need something like results. And then we want to push on whatever that value is, right? We have to declare it before. Exactly. So we'll declare it on the very first line. And then down here, we don't want to just return an empty array, right? We have our new results array that we can return. Awesome. How come I can use, should I use const? We have to use let? We have to use let? Hang on one second. Do we have to use let? How come I can get away with const here? Arrays are objects. That's right. That's right. You just like you can change the properties on an object after the object's been created. But we're not actually changing the object itself. At no point did we say results now equals some different array, because this is going to error out on us. Assignment to a constant variable. But pushing values into an array or adding new keys to an object doesn't actually change the object itself, right? So we can use const very safely here and not worry about it. So my rule of thumb is use const until it tells you not, until you see this assignment to a constant variable, and then go, oh, okay, I should have used let in that case. JavaScript will tell you, okay? But you're safe to pretty much always use const. And you'll see that I use const everywhere except inside of where I is changing, right? Okay, so let's get rid of this. We've got our everything on there. Awesome. Make that one smaller. Hopefully that's not too small so that we can see everything on here. So we wrote our own filter function. We wrote our own filter. Then we passed in our test. It might be easier to call this like test, because it's going to return either true or false. And then we returned an array with new values, and then we console log those new values, right? And we see that our output is exactly the same as we got from array.filter. Okay? So, has anyone ever seen Python Tutor? Have any of the other lecturers introduced you to Python Tutor, or you've played around with it on your own? So, this is a fantastic website that will actually step through our code. You can actually just copy your code from VS Code, or you could live code right into here. Select your language. In this case, it's JavaScript. It already knew because I went to the JavaScript page. But you can use Python, as you can imagine, in various different languages if you want to see what happens. And then we can click on Visualize Execution. And it takes us to a new screen. So this screen is, how's the font size? Is that too small in the back? I zoom in a little bit. There we go. Okay. So here's our code that we wrote. This is our new filter function. And the red arrow points to the next line that will be executed. And the light green arrow, I know that's not very contrasty, points to the line that has just been executed, as in the previous line. Okay. So we know that JavaScript executes from the top to the bottom, right? It reads through your code. So let's watch this thing move. I'll have to make it one smaller so we can step forward. Okay. So the first line of code ran. The red arrow points to the next line of code that will run. The first line of code ran, this one. And what did it do? It actually created an object, an array, in memory with the values Zuckerberg, Wahlberg, and Ruffalo. And it named this marks. We have a hook to access that array in memory, right? We can make reference to it with marks. Cool. Okay, next line of code. Const filter. What is this going to do? Let's step forward one. Hey, cool. Filter. But notice that this was the line of code that ran. Line 3 ran, but we're now jumped all the way down to line 13. Because this code here is the equivalent of this. The Zuckerberg, Wahlberg, the array literal. We're simply saying create a variable called filter and attach as its value a function. And so the JavaScript interpreter saw this as one line of code, the equivalent of this. So that's why we're skipping down. It said, whatever's in here, put this into memory. You can make reference to it later by saying the word filter. Cool. Let's step forward again. We're now down to line 13. Ooh. Probably unsurprisingly at this point, we now have a variable in memory called test, and it is an arrow function in memory. And you'll notice that these are not named down here. These are what we would call anonymous functions, right? Because this is just the value of the function. We've attached a name to it up here. We can say again later. Is everyone following along? Doing good? Awesome. Okay, so we jump down to line 17 now. Const new marks equals filter marks test. Let's step forward. Ooh. Okay, so now we've got something going on here in the global frame. So we're up to here. Our next line of code that we'll run is this results array, but the first thing we did is set up new marks here. So we now have a results array that has a value of undefined because we've declared it, but we haven't defined it yet. And we see that the callback that was passed in, this callback, actually points to the same function that test points to because we passed in a reference to the function. We said, here's our reference to that point in memory. There's this awesome functionality that lives there. I'm giving it to you now. I'm passing it to the filter function. So the filter function says, great, I've got an array that points to marks, points to the same object in memory. Note that R doesn't point to marks. It points directly to the object in memory, okay? And same thing with callback, points directly to this object in memory. Okay, cool. What's next? Ooh. Results is an empty array now. It was undefined, but we stepped one forward. And now it has a value in it. It's an empty array. And we see that we also have results in block 1 is undefined. Cool. Let's find out what that means. So now we're going to step forward. Ooh. Here's our I has just fired. And what is I the first time through? 0, right? We actually explicitly said, let I equal 0. This is our starting point. This is where we're going to go from. Okay, next line of code to run. Step forward. So we're going to if callback. So the next thing that happened was our conditional was evaluated. You can actually have for loops that never ever run. Just like you have an if conditional. If object has this property, do something with it. You don't necessarily have to have an else, right? So we can also have for loops. Let's say that this wasn't I is less than r.length. Let's say I was less than 0. Then setting I to 0 means that this for loop would never actually evaluate. Okay? So we actually had to test that. And we said, okay, I, is it less than r.length? It is. Perfect. We're actually going to do something. So we're stepping into here. And we're going to move one step forward. Okay. So we made it inside of here. This line is being evaluated, and it actually jumped through. I believe it's yes. Let's see. We jumped through. We tested. The first one through is Zuckerberg, so that fails our test. And if we jump through again, we see that we've actually gone back up. I'm going to unread these. There we go. So the first time through, we evaluated this code. We said, if the first one through, if Zuckerberg does not equal Zuckerberg, then push it into the results array. But we see that our results array is still empty. So it failed the test, right? So then we reach the end of the for. We jump right back up to the beginning of the for loop again. What do we do at the end of the for loop? We increment I, right? So I is now 1. Okay? And we're going to evaluate the 1th object, or the 1th string inside of this array. Wow, look at all this clicking. Okay. Step through again, step forward. Okay, we're going to evaluate. We're going to pull that piece out of the array, and we're going to test it against our condition. Now we actually jumped into our test. We actually said, hey, does this not equal Zuckerberg? Hey, set a variable called name equal to Wahlberg. Great. Or return this Boolean value. Great. Return value is true. Awesome. Because we passed in name here, which was equal to Wahlberg. Then we compared it to Zuckerberg, and we got a return value of true. Awesome. So now we jump to this line. It evaluated to true. What do we do with it? We push it into the results array. Hey, there we go. Now we've got an array with 1 item in it. What do we do again? We go back up. We increment I. We test our condition. Is I less than r dot length? R dot length is 3. I is now 2. That's true. We step back into our for loop. Ooh. Now we passed Ruffalo. So see here where we said call the callback and pass it the next element. The next element is Ruffalo. That gets passed into here. Is Ruffalo not equal to Zuckerberg? Let's find out. Oh, that's true. Great. So what's the next line of code that'll run? Into our results push. We're going to push Ruffalo into our results array. Let's step forward. Hey, there we go. Our results array has Wahlberg and Ruffalo. So you might think, well, aren't we done? Shouldn't we jump down to line 17? But that's not actually what JavaScript's going to do. Because we're inside of a for loop. And what do for loops do? They loop until the condition is false. So let's step forward again. And now, the I gets incremented, and it becomes 3. So we say, is 3 less than 3? Well, it's not, right? So what are we going to do next? We're going to return the results array, which holds 2 values in it. Step forward again. There's our return value from this function, is this array. We're going to step forward. New marks is going to point to this array in memory. And then we ultimately console log our new marks to the console. So we took an array that looked like this, and we filtered it and returned a brand new array that looks like this. We've removed those values from it. Was this helpful? Oh, there's our output printed. Was this helpful to look through Python Tutor and see how it actually stepped through your code? And you can put any code that you want in here, and you can step forward through it. You can see what it's doing. Is it doing what I think it's doing? And this is a very neat resource to show you how objects are put into memory, how they're stored, how your code is actually running. Okay? Yes, yeah, absolutely. I will for sure. Okay, so implementing our own for each and or our own filter, and we managed to do both. So it is 11:54. My goal was that by noon, everyone would know what a callback function was. Okay, so let's revisit this. A callback is a function. Whoa. A callback is a function that gets passed to another function to be invoked by that function. Does that make sense now? You have 6 minutes for questions, asking me to do something else. Anything? Anything stirring? This is it. I can't stress this enough. You are going to see this absolutely everywhere, because the idea of separating these concerns, the idea of here's my logic that I want to run, but I also want to iterate over an array, or I want my web server to listen for a new user to log in, something like that, and then we call this code. I want to iterate over each element and call the code every single time. Stuff like that. You are going to see this, the callbacks, absolutely everywhere in JavaScript. Okay? Anything else? Any questions? Anything? Okay. Mm-hmm. Let's see. So the question was, why did the results block? Where are we? If we go back, this results block, which one was it? This one, results block 1. It's actually because it's showing what I started at. It's saying like, we initialized it to 0. So it's just showing us it started at 0, but now it's 2. Okay. Any other questions? Wow. Yes. Oh, sure. Do you have an example of a function that doesn't just say hello? Okay. Sure. Touch, for lack of a better term, real life.js. There we go. Okay, so where would you want to use this? Okay, so let's say that we have an array of users. And each one of our users is an object that has a username and a Boolean value. And then we're going to copy this a bunch of times. Okay, so we need some other users. So we'll have Alice, Bob, Carol, Denise. I need an E name. Elizabeth, F, Francis. There we go. Cool. And they're not all going to be not logged in. Some of them are actually going to be logged in right now. So what you would absolutely do in real life is you'd say, okay, I want to do something with all of the users that are logged in. I want to send them all a message and say, thanks so much for being part of our site. Something like that. I want to take some kind of action, but just for the users that are currently connected to my server. Just for the ones where logged in is true. Okay, well, I would do something like const logged in users equals users.filter. We're going to take the user, and we're going to return not, or u.logged in. And here we can console log our logged in users. Okay, so if we run this, node real life, we'll get back an array of just users that are logged in. And so obviously we just console log this, but then you could move on from there and say, okay, now I've got an array of everyone who's logged in. I want to iterate over that array and send everyone a message, or update everyone's account with an extra bonus because they're using our app right now. They were logged in when we ran this function. Okay? And this is kind of the way that you'll use it. You'll get results back from a database, but you'll say, I don't want all of the results. I want a subset of those results. Or I want to transform all the results. Let's do another one called we'll actually just console log users once we're actually, that's not going to work, is it? New users, and I'm going to say log everyone out equals users.map, because map actually will transform all the elements of the array. So here we're going to say u.logged in equals false. And then we're going to console log new users. So we should see new users is not defined. Hang on. Const new users. There we go. Clear. Clear even. So we see that we actually got back an array that was just false, 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 false. Oh, because we're returning. See, this is where your curly braces. Okay. So we want to transform the user object, whatever it is, we want to return. We want to say u.loggedin equals false, return u. I'm just using a shorthand here. I should probably actually change this to user, user, and user. And so now we look at this and we see that all of our users are now logged out because we mapped over the array and we changed all of their values inside of there. But again, why did we use this? A separation of concerns, right? Map walks over every element in an array, performs some kind of data manipulation or transformation on it, and then returns an array of the same size, right? And so that's what map does for us. And then we passed in our own specific functionality that said, when you're given each one of these users, do this. Change the fact that they're logged in to false, and then return the user. So we get it back again. This is just one example. You'll see it all over the place when we start using web servers as well. Okay. 12:01. Are we good? Awesome. Thank you so much. I'll be available today for questions. Otherwise, reach out to me on Slack. Cool. Thank you for your time.